by integrating our equation between 0 to d by 2. Why we are taking 0 to d by 2? Because you can see over here that above neutral axis, if I assume that this is the depth d, right? If this is the depth d, so this portion will be d by 2, right? So this will be 0, and as we keep on increasing, it is d by 2. So our limit will be 0 to d by 2. So if I want to find out the shear stress distribution above neutral axis, my limit will be 0 to d by 2. So shear force F, that is equal to integration 0 to d by 2, right, into del m upon I into y into a into dy. So delta m upon I is a constant, a into y into dy. So a into y dy is nothing but ay bar, if you recall your CGMI, right? So a is area of beam above neutral axis, y bar is the distance between CG of area and neutral axis. So now shear stress, that will be equal to total unbalanced shear force divided by area. So shear stress is denoted by tau. So tau, that is equal to total shear force, that is delta m upon I into ay bar upon area. So what will be area? Area will be nothing but the width of the strip EF, that is B, into del x, that is length. And delta m upon delta x is nothing but shear force. So tau, that is equal to F A y bar upon BI. Okay, so F A y bar upon BI, that is nothing but the shear stress. In certain books, instead of F, they have written S. Okay, so to remember, it is very simple, say by. Okay, so tau, that is equal to say, SAY, that is say upon by. Okay, now what is this S, what is this A, that we will define, and you can easily remember this by equation say by, where S is equal to maximum value of shear force. Okay, now how do you get the value of shear force? How do you get the value of shear force? If you will recall that whenever we have solved numericals for shear force bending moment, we have observed that the value of shear force is always maximum at the support. That means you have to calculate the support reactions to take the value of shear force. Okay, but you will get two values of shear force if the loading is not symmetrical. That means when we are getting two reactions, the maximum value of the reaction you have to take. For example, if I say that you have got a simply supported beam subjected to a central load W, then what will be the value of reaction? The value of reaction will be half, that is W by 2, W by 2. So at both the supports, the value is same. So we'll take the value of shear force as RA is equal to RB is equal to W by 2. But suppose the loading is that you have got a simply supported beam subjected to uniformly distributed load as well as a point load. Then in this particular case, you have to calculate the value of support reaction using our three conditions of equilibrium, that is sigma h is equal to 0, sigma v is equal to 0, and sigma moment is equal to 0. Using these three equations, you get the value of RA as well as RB. So whichever value is greater, that value you have to take, and that will be the value of shear force S. Okay, so you got it, how to take the value of shear force. So S is nothing but the value of shear force, that is also the maximum value of shear force that you have to take, which we will get by calculating the support reactions. Okay, now A. What is A? A is nothing but the area under consideration. Very important. Why area under consideration? Right? Now when I had derived the formula for the shear stress, right, we had considered the area above neutral axis. Okay, that means wherever I have to calculate the value of shear stress, I have to consider that value of area. If I am considering the neutral axis, then I have to take the area above neutral axis. If I am taking for the line EF, then I have to take the area above line EF. So A is the area which we have to take under consideration. Then Y bar. What is Y bar? Y bar is nothing but the distance of CG of area under consideration with respect to neutral axis. Okay, that means again if I take this particular problem, right, if I am taking above neutral axis, so this is my shaded area which I am taking, right. So what is its depth? D by 2. So if I want to find out the value of CG, intersection of diagonals will give me the value of CG. So CG of shaded area with respect to neutral axis, what it will be? D by 2 is the depth. So half of D by 2 will be what? D by 2 by 2, that is D by 4. Okay. So Y bar is that. B. What is B? B is width of section. Width of section. And I is moment of inertia. Okay. So this is the shear stress formula to find out the value of shear stress, that is tau, that is equal to say upon by. Okay. Now we will derive the formula for the rectangular cross section of a beam. Okay. So to derive the formula for a rectangular cross section of a beam, we are taking a rectangular beam having width B and depth D, and the beam is subjected to a uniformly distributed load. So first of all I will draw a rectangular section because we are deriving the formula for shear stress for a rectangular section. I will write the dimensions. Its dimensions are depth D and width B. So depth D and width B. Then we have to locate the neutral axis. So now you all know, to locate the neutral axis we have to intersect the diagonals. So when we intersect the diagonals, the point at which both the diagonals meet, that is the position of centroid, and from that centroid the line which passes is called as neutral axis. So we have located the value of position of neutral axis, and the distance will be half of the depth, that is D by 2 and D by 2. Okay. So we have located the position of neutral axis. Now we will take a section, that is small section A, B, G and F. Okay. We are taking a small section A, B, G and F, and this small section is lying at a distance of Y from neutral axis, is lying at a distance of y from neutral axis. Now the intensity of the shear stress at this particular section is S. So we can say that let S be the shear force. Okay, as it is a force, what will be its unit? Its unit will be kilonewtons or newtons. Okay, and the shear stress will be tau. So shear stress will be tau. Okay, and the formula that we have derived for tau is what? Tau, that is equal to say upon by, right? Now if I want to derive the unit for shear stress, what will be the unit for shear stress? We can say that shear force is in terms of kilonewtons or newtons, area is in terms of mm square or meter square, y bar is nothing but distance, so it is mm, then the width is again nothing but in terms of meter or mm, and I is moment of inertia, that is mm to the power 4. Okay, so this mm square and mm, that is mm cube, will cancel out, so we will get the final answer as tau as Newton per mm square. Okay, so tau is shear stress and its unit is in terms of Newton per mm square. Now what students make mistake is that they put the shear force in terms of kilonewtons and then they put the value of area as well as moment of inertia in terms of mm. No, all the units should be in same, either in CGS or MKS or FPS or SI. Okay, that means if you're putting the force in terms of Newton, then the area should be in terms of mm square. Moment of inertia should also be in terms of mm square. So try to remember the conversation. Okay, now so the unit of tau is nothing but Newton per mm square. So again we talk about our section, that is ABGE, which is subjected to shear force S and shear stress tau, where AY bar is nothing but the moment of area of ABGE with respect to neutral axis. Okay, so now I will draw our small area, that is ABGE, so that you can easily understand. So this is our area, shaded area ABGE. Okay, and this is, if the distance, if I say, what will be the distance this? So you can see over here, this is d by 2, right? And this is y. So what will be this much distance? D by 2 minus y. So I can show over here that this distance is d by 2 minus y. Okay, and this is our width b, so we can show that this is the width b. Okay, this is our shaded area we are taking into consideration. Okay, so now shear force, as we know, we want to find out first the area. So what will be the area A? So I am writing down small a. So area of ABGE. What will be the area of ABGE? So that will be equal to B into D by 2 minus Y. Okay. Second is CG, centroid of area ABE. So again, intersection of diagonals. So that will be equal to y bar, and that is nothing. So this is our y bar. Okay, and this y bar is equal to half the depth of ABGE. So 1/2 depth of ABGE, and that is equal to 1/2. What is the depth? D by 2 minus y. Okay, so we have calculated area A, we have calculated y bar. Now width of the section. So what will be the width of the section? So the width of the section is nothing but B. Okay, you can see width of the section, that is nothing but B. So we can say that width B, that is C, that is width, and width, that is equal to B. And last is moment of inertia I. So what is moment of inertia I of a rectangular section? BD cube by 12. Okay, moment of inertia for a rectangular section is BD cube by 12. So now if I want to find out the value of AY bar, we can find out the value of tau, that is equal to SAY bar upon BI. Okay, so what is the value of area A? So area A we have calculated as B into D by 2 minus Y. Okay, then what is the value of Y bar we have calculated? Y bar we have calculated as D by 2 minus Y and half. So I will write down 1 by 2. Okay, upon width. So width is B and I is BD cube by 12. Okay, so when we substitute all these values and solve the equation, then we get the value of tau as tau is equal to 6s upon BD cube into D square